Welcome to today's lesson. For today's lesson, we'll be handling digital electronics, specifically the logic gates. Logic gates can be defined as combinational circuits that are used to handle Boolean expressions. Yes, for logic gates, there are two types of logic gates. There is the basic gates, and there are the derived gates. For today's lesson, we'll be handling the basic gates. There are three types of basic gates. That is the AND gate, there is the OR gate, and there is the NOT gate. The NOT gate. So, and all these tables, all these gates, we'll be looking at them in detail below. But before we look at the gates, I'd like to mention the truth tables. So for each of these gates mentioned above, we will draw their truth tables. Truth tables list all the possible combinations of inputs and outputs that can be gotten from all the inputs that are fed into these gates. So the truth tables will be giving us all the possible combinations of the inputs. So we will start with the OR gate. So I will simply give a drawing of the OR gate and then I will explain. So for the OR gate, it is drawn as so you will allow me to use the inputs A and B and the output will be Y. So for the OR gate, it can be described as for all the inputs that are put into this OR gate, for all the inputs, the outputs, for all the inputs, it gives, for all inputs, it gives logic O as the answer, except it gives logic O as the answer for all the inputs, into this gate. It gives only logic O when the inputs are 0 and 0. For all the other possibilities, for all the other possibilities and combinations, the answer will be logic 1. So that is simply to describe the OR gate. So if I may repeat, for all the inputs into the logic O, it only gives, for all inputs, it only gives logic 0 when all the inputs are 0 and 0. For all the other possibilities, maybe 0, 1, 1, 0, and 1, 1, the answer, the output will be logic 1. So to draw the truth table, so we'll draw the truth table for the OR gate. So will allow me A, B, and Y. So 0, 0, 0, 1, 1, 0, 1, 1. As explained earlier, only 0, 0 will give us logic O. For all the other combinations, it will be 1, 1, 1. So this is the truth table for a 2 input OR gate. So that is the basic OR gate. For the next one, we'll handle the AND gate. So for the AND gate, I will also draw the gate, and then I will give an explanation. So for the AND gate differs slightly from the OR gate. For all inputs into the AND gate above, you will get logic 0 for all possibilities except when the inputs are 1, 1. So when the two inputs are 1, 1, for this one, you'll get logic 1 as the answer. For all the other possibilities, you'll get logic 0. Yes, so that is the AND gate. To draw the truth table, we'll draw the truth table. So the truth table for the AND gate, it will be slightly different to the one of the OR gate. So as explained earlier, the answer, the output for all these possibilities will be 0, will be logic 0, except only when 1, 1, it will give logic 1. So that is the truth table for the AND gate. Yes, so next we'll handle the NOT gate. So the NOT gate, it is a very simple gate. I will draw it and then explain it. So the NOT gate, it can be simply explained that the output of the NOT gate, you get the complement of the input that you put in the above. So for Y, so for example, if you input logic 0 into a NOT gate, your output will be logic 1. And vice versa. Right? If you input logic 1, the output will be logic 0. So the NOT gate gives you the complement. Complement of the input given. So the output is the complement of the input that is given. So to draw the truth table, so the truth table for the NOT gate will be very simple, because it is a one output system. So for 0, it will be 1. For 1, it will be 0. So that is the truth table for the NOT gate. So as seen from the 3 basic gates described above, described in this lesson, we can learn that The three basic gates, they simply used in electronic devices to give us the outputs based on the inputs that are given. They give different outputs based on the gate that you are using. So you can use the AND gate, the NOT gate, or the OR gate. For the next lesson, we will describe the derived gates.